I'm going to carry out the food test today on some samples of biscuit. I'm going to test for monosaccharides, disaccharides and starch. Then I'm going to follow up by testing for oils and finally proteins. So for the first test I'm going to test for monosaccharides. What I need to do is to crush up the food sample, just to break it down, and then add about half a container full of distilled water. So aim to about half fill the pot, break it down thoroughly. The object is to get as much as possible into solution. The food tests themselves are quite sensitive, so you don't need to aim for 100% dissolving. That should do nicely. What I'm going to do now is to divide this substance into 3 test tubes. So I'm going to take a piece of filter paper, fold it in half again, and then that should fit nicely into this funnel. The object is not to get a 100% filtering job done, but essentially just to avoid getting too many of the claggy big bits going through. So we'll start off by tipping that in like that, and then I'm just going to change it over. I can go into the next test tube now. And so we'll leave that dripping, and then when that's about up to the same level I'm going to transfer across. In fact, I'll do it now. Over we go into the final test tube. We're going to do these tests one at a time, so whatever you do, don't use all 3 tubes up on the very first test that you do, otherwise you'll have to start grinding and adding water again. So this is my test tube. I'm going to label it because I'm going to test for monosaccharides, so I'm just going to write mono on there and my initials, just so that I can keep track of it, because the test tubes are going to go into a water bath along with everybody else's. What I'm then going to take is some Benedict reagent. Benedict's reagent contains copper sulfate. The copper sulfate will react with any glucose that's present, or indeed any reducing sugar, and that includes monosaccharides. And it will convert the copper sulfate to a red copper oxide. So I'm going to add approximately the same quantity again of Benedict's reagent. Don't need to be too finicky about the amount. That should do nicely. And then I'm going to place it into this thermostatically controlled water bath here. It's set at about 75-80 degrees, and I'm going to leave that there for around about 10 minutes, no more than 10 minutes, between 5 and 10. And what I should see then, if there are any monosaccharides present in the sample of biscuit, I'll be able to see a change of colour. So it's now 5 minutes since I put the sample in. I'm going to just check it now, and this is a positive test for monosaccharides, or specifically for reducing sugars, and I would suspect that this particular one is glucose. You'll find when you look on the instruction cards that there are a range of colours you might get. This shows that there is a lot of glucose present. A green colour or a yellow colour denotes less or little glucose present. If on the other hand there's been no colour change at all, and you've still got a pale blue colour, then essentially you know that that's a negative result. So I'm going to leave that back in the water bath there, just out of the way, or better still, I'll pop it into the test tube rack here, and it'll be out of the way. Now sometimes you'll find that you get a negative result for this, and what you then need to do is to go on and test for disaccharides or non-reducing sugars. And we're going to do that anyway, just to give you a chance to actually practice the procedure. So ignore the result of the first practical and carry on and do the test for non-reducing sugars next. Basically, you've got your second test tube here. The problem with non-reducing sugars is that they don't react with Benedict's reagent. That's because they're disaccharides. So if you imagine that this is the bit that actually reacts on the glucose molecule with the Benedict's reagent, resulting in a red colour, in the case of a disaccharide, the two monosaccharides are bonded together, and that reactive group is actually concealed. So what we need to do, if we're going to test disaccharides, is to essentially split the bond between the disaccharides, which will reveal the reactive group, and we can then carry out the Benedict's test. In order to do that, what we're going to do is we're going to add some hydrochloric acid. So what I'm going to do is I'm going to add about 5 drops of hydrochloric acid. The exact amount isn't critical. What that's now doing is it's cleaving apart the bonds of the disaccharide. What we need to do now is to neutralise that reaction so it doesn't go too far. I'm going to add 5 drops of the same strength but of sodium hydroxide. So there we are, that's now neutralised, and we then just follow up by adding our Benedict's reagent. So again, we're going to double up this quantity here, like so. I'm just going to label up that test tube. I'm just going to put di on there for disaccharide, my initials on the back. I'm going to pop that back into the water bath and again leave it for 5 or 10 minutes just to see if there's a colour change. My final carbohydrate test is just to test for polysaccharides. We don't use the Benedict's test for this. Essentially all we do is we take a sample of the dry food and we add a drop of iodine to it. If a blue-black colour ensues, then we know that we've got starch present. If there's no change, then that's a negative reaction.